Hello everyone, this is Mr. D, and today we'll be going over the AP Computer Science Advanced 2025 FRQs. So question 1 begins with, this question involves dog walkers who are paid through a dog walking company to take dogs for 1-hour walks. A dog walking company has a varying number of dogs that need to be walked during each hour of the day. A dog walking company is represented by the following dog walk company class. And here's the class, and these two methods will be our helper methods for what we will be writing in the dog walker class. So yes, dog walker is associated with a dog walking company and represented by dog walker class. You will be writing two methods, and those two methods would be walk dogs and dog walk shift. So part A, write walk dogs method which updates and returns the number of dogs this dog walker walks during a specific during the time specified by hour. Values of hour ranges from 0 to 23 inclusive. A helper method, num available dogs, has been provided in the dog walk company class. The method returns the number of dogs available to be taken for a walk at a given hour. The dog walker will always walk as many dogs as the dog walking company has available to walk, as long as the available number is not greater than the maximum number of dogs that the dog walker can handle, represented by max dogs. Another helpful class is update dogs. Uh, I mean, uh, has also been provided by the dog walk company class, so that multiple dog walkers do not sign up for the same dogs. The the walk dogs method should use update dogs to update the dog walking company with the number of dogs this dog walker will walk at during the given hour. The parameters of update dogs methods include the number of how many dogs this dog walker will walk during the time specified by hour. And here it just goes through an example. And yes, and the walk dog should a method should return the number of dogs to be walked by this dog walker during the specified hour. So let's work on this. So what we know here is that when we first call on walk dogs, we pass an hour, and we want to see how many dogs are in that are ready for that hour. So int, I'm going to call it available dogs equals company dot num available dogs, and we're going to pass that same hour. This will give us the amount of dogs that need to be walked in that hour. Then I'll put another integer, int dogs walked, set that equal to 0 if available uh, available hold on. Yes, sorry about that. If available dogs is less than or equal to max dogs, which max dogs is a instance variable, then we can just say dogs walked is equal to uh, available dogs. And else dogs walked is equal to the max dogs. So we got the first part done, which we'll see like how many dogs will walk. The next part the updating the amount of dogs that need to be walked, and we'll do that through company dot update dogs hour dogs walked semicolon. Forgot the semicolon over here. Uh, return dogs walked. So that's part A. Uh, it does it does everything that you need to do. It'll see what amount of dogs you'll walk, after which it will update the dogs that need to be walked or update the dogs, and then it'll just return the amount of dogs that you walked. Now, part B, write dog walk shift method, which performs a dog walking shift of hours in the range of start hour to end hour inclusive and returns the total amount earned. For example, a dog walking shift from 14 to 16 is comprised of 3 1 hour dog walks starting from 14, 15, and 16. Uh, for each hour, the base pay is $5 per dog walked plus a bonus if at least one of these things are true. So max dogs are walked, or the walk is during the peak hours of hour 9 to hour 17. And here's an example. So let's get to that. So let's do the same idea of what we did earlier with dogs walked equaling 0. Oh, and then let's add another variable called, I guess, bonus counter or bonus count. And let's set that also equal to 0. So what we're going to do with dogs walked is that we're going to have a list, I'll have a loop that starts at start hour, ends at end hour, and we'll keep on adding the amount of dogs that we walked to the dogs walked variable. And if we ever fulfill a bonus condition where we can earn a bonus, then we will update the bonus counter, and we'll do that via for int I is equal to start hour. Uh, I is less than or equal to, because it's inclusive of the end hour, and then we'll do I plus plus. Then we'll have int walked. This is just like a temporary variable. Walked dogs. Oh wait. We're gonna call the method walk dogs. And then we're gonna input I, which is gonna be the specific hour that we walk in. Then we're gonna increment dogs walked with walked, so it's gonna be plus equals walked. And then now we need to check for our bonus conditions, which would be if, and it's two conditions. If I is greater than or equal to hour 9, and I is still less than or equal to hour 17. So that's the hour requirement, or when the amount of dogs walked is equal to max dogs. And then what we're going to do from there is, if that's successful, we will increment our bonus counter. And then now that we have that done, we can just return our salary, which is going to be return 5 times the number of dogs that we walked, so dogs walked, plus 3 times how many times 3 times the bonus count, which would be 3 times bonus counter. And that's how you would do part B for the AP exam. Question 2 is our class question. So this question involves a signed text class, which contains methods that are used to include a signature as a part of a string of text. You will write the complete signed text class, which contains a constructor and two methods. The signed text constructor takes two strings. The first parameter is always the first name. The second parameter is a last name. The length of the second parameter is always greater than or equal to 1. So we know that, so basically what we can get from this is that the first name may or may not be empty, but the last name will always have some real string value to it. So then we get into our methods. The get signature method takes no parameters, so it's a getter method. Turns the formatted signature or string constructed from the first and last names according to the following rules. And then we have, if the first name is an empty string, the returned signature string contains just the last name. If the first name is not an empty string, the return signature would be the first letter of the first name, followed by a dash, and the last name in that order. So that's the get signature class. Then we have add signature. The add signature method returns a possibly revised copy of its string parameter. So we are passing a string to this method. The parameter will contain at most one occurrence of the object's signature. So that's another important one. So we're not going to see the person's signature twice on the string. At either the beginning or the end of the parameter, the return string is created from the parameter according to the following rules. If the object signature does not occur in the string parameter of the method, the return string is the value of the parameter with the signature added to the end. If the object signature occurs at the end, it will just return the unchanged parameter. If the object signature comes at the very beginning of the string, it's going to be returned where the signature will be removed from the beginning and just be placed at the end. So, and here we have the examples for it. So let's get started to write the signed text class. So we have our instance variables of type string of our first name and last name. Then public sign, and this will be our constructor, signed text of the parameters string first name and second parameter string last name. Uh, then you're going to use the this modifier so this dot first name is equal to first name, and then this dot last name is equal to last name. So that's our constructor done. Let's now do the get signature method. So public string get signature has no parameters. It's a getter method. And if yeah, okay, so if the first name him the length is equal to 0, it's going to be an empty string. So what we do is we just return the last name. However, if it's not empty, we return the first letter of the first name. So we're gonna have first name dot substring from 0 to 1 plus uh, a dash plus the last name. So that's how we do the get signature class. I mean, the get signature method. Now we have the add signature method. So if we do public string add signature, then we have a string of an input text string. I'm gonna put signature is equal to our formatted signature of get signature, and then I'll just make it slightly easier since I don't have to do many more method calls. If so this is where the logic comes in. So let's do the first case in where we try to find in the case where the signatures at the very beginning of the input text. And the way that we do that is, well, first off, we can't, for the sake of logic, and I'll explain this a little bit later, we're only going to evaluate it if input text, the length of input text is longer or equal to the signature length. Because, if it is shorter, then there's no possible way that the signature that could contain a signature, and we can just go ahead and return what the default case basically. So what we're gonna put is inside this if statement. So that means the input text is larger than the signature length. So let's do the first case of the signature is in the front. So the way that we could check for that is to say that if input text dot substring from 0 to signature length is equals signature, then that would mean that they're the same. I mean, the signature is included in the very first portion of the input text. So what we do is we just return the input text dot substring from signature length and then we do plus the signature. The next case is if the signature is at the very end. So the way that we check for that is else if input text dot substring is from input text dot length minus signature dot length, and so we check from there, and we evaluate it. So dot equals signature. That means like the text ends with the signature, then we don't need to do anything to the text. We just return the input text. So there's that. So that's the special cases, but the default case is we turn the input text plus the signature. So that's the second question on the class question. Go to the third one. Third one, this question involves pairing competitors in a tournament into one-on-one matches for one round of the tournament. For example, in a chess tournament, the competitors are individual chess players. A game of chess involves two players in a match. The winner of each match goes to onto a match in the next round of the tournament. Half the players are eliminated in each round of the tournament. There's eventually a final round consisting of one match and two competitors. So this is all just extra stuff to sort of waste your time with. Uh, Here's where we had to start reading from. Competitors' matches in rounds of the tournament are represented by the following classes. So this is the competitor class where we have to supply a name and a rank. This is the match class where the constructor requires a competitor 1, competitor 2. And this is the round class where we're going to be putting our code in for the constructor and the build matches method. So that's what we have to do. So part A is the constructor. Write a constructor for the round class. The, the constructor should initialize competitor list to contain one competitor object for each name in the string names. The, the order in which competitor object appears in competitor list should be the same as the order that they appeared in the names. The rank of each competitor is based on the competitor's positions in the names. Uh, the names are listed in names in order from best ranked competitor with rank 1 to the worst ranked competitor with rank n, where n is the number of elements in name. So here's an example of it where we see that the 0th index would have rank 1, that's Alex. First index would have rank 2, that's Ben. Second index would have rank 3, that's Kara, and that would be the worst. So let's do that. Part A. So we have, remember the instance variable of uh, competitors. Yeah, competitor list. So we need to supply that. So we have competitor list of uh, competitor list is equal to new array list of, we had to put the parametric type of competitor, and we had to put, and then we put empty parentheses. Then we just iterate through the list. So for int I is equal to 0, I is less than names.length, and I plus uh, we supply what is needed for each competitor, which is a name and a rank. And remember that rank is the index of the list plus 1. So we have competitor list dot add new competitor of the names I with the rank of I plus 1. That's all we had to write for part A. Part B, write the round method, build matches. This method should return a new array list of the match class or the match object by pairing competitors from the competitor list according to the following rules. If the number of competitors in competitor list is even, the best ranked competitor is paired with the worst ranked competitor, second best rank with the second worst, etc. If there's an odd number of competitors, the best ranked competitor is ignored, and you follow a similar rule to the even number. So here we see that where we have an odd number, we have the last rank being third, so we only have one competition. And here we have an even number list, and we get two competitions from it. So uh, to navigate through this type of list, we need to a little bit employ more. We need to think about how we traverse through our list exactly. So let's see what the basic example. Let's say that we have 1, 2, 3, and this is just a small abstraction before we get into the code. So this is an even case. So we have 1, 2, 3, and we want to break it up into 1, 4, and 2, 3. So how are we going to do that? Well, so in our first iteration, we have to, so let's say that I is equal to 0. We select the 1 case and the 3 and the 4 case. And then when I is equal to 1, we select the second case and the third case, and then we stop. So the amount of iterations that we have is, well, it's going to have 2 iterations. Or if we were to put this into similar code, we're going to start off at I is at 0, but we ended at basically the halfway point. So we're going to end it off at I is less than 2. And we can see this, and we can generalize it. Say we have a 6-member competition or a 8-member competition. What we see is that trend is it's going to be the length divided by 2, and that's sort of what we want to get at. Now, that's assuming that's even. If we have odd, so we have 1, 2, 3, 4, 5. Well, essentially, it's the same as the even number, but we just omit this. So we just get rid of that, and then we just do the same algorithm. So essentially, what we're doing here, we're starting I at 1, and from there, if I'm not wrong, we just still do I is less than 2. Um, yeah, if we can like go through it. So we omit 1. So when I is equal to, oh, we still start at actually I is equal to 0, and we still go with 2 because the reason why is we don't consider 1 in the first place. So we have 1, 2, we select 2, 3, 4, and we pair that with 5. Then when I is equal to 1, we go with 1, 2, we select 3, pair that with 4, and then we go with 5. So essentially, we have the same algorithm, but we just start at a different value. So if we were to apply that, we see the following. Where we have public array list match build matches of start off with an array list that we're going to construct. Array list match of the parameterization match. We're going to call this matches, and we're going to have new array list of the parameterization match with an empty parentheses. Then we're going to have, for the sake of simplicity, we're going to have something called a size variable to just be the competitor list dot size, and then we want to now deal with the odd case. So remember, for odd case, it's exactly like it's the same algorithm as even, but we just start at index 1 instead of index 0. So start off with the basis that int start is equal to 0, and if there's an odd number, so size modulus 2 is equal to 1, then we set start equal to 1. And then once we do that, we'll go to our algorithm that we established for int I is equal to start, int I is equal to 0, and then this is where we do the special iteration method thing where we do size minus start divided by 2. Then we do I plus plus. And then we just iterate through the loop by saying matches dot add new match competitor list dot get to start plus I comma competitor list dot get the size is size minus 1 minus I. We do the minus 1 because if we were just to do size, we're going to get is an index out of bounds error, because size would be the last index plus 1. So let's do that, and then you just return your matches. Return matches. So I would say that's probably the most difficult question, part B of question 3 for this 2025 exam. And now we're on the final question, the 2D array question. So the next, yeah, okay, there we go. This question involves reasoning about a number puzzle that is represented by 2D arrays. Each element of the array initially contains a value between 1 and 9 inclusive. Solving the puzzle involves clearing pairs of array elements by setting them to 0. Two elements can be cleared if their values sum to 10 or they have the same value. The puzzle is considered solved if all elements to the array are cleared. And this is our constructor. So you will write the constructor in one method of the following class. So here and here. So the constructor, write the constructor for some or some same game class. Constructor initializes the instance variable puzzle to be a two-dimensional array with the number of rows and columns specified with the parameters num rows, num columns, respectively. Array elements are initialized with random integers between 1 and 9 inclusive, each with an equal chance of being assigned to each element of the puzzle. right, when when an element of the 2D array is assessed, the first index is used to specify the row, the second index is used to specify the column. All right, so if we were to write that, we would get puzzle, because that's our instance variable. Puzzle new is a new 2D array of integers, a new int of num rows and num columns. Then we have for int I is equal to 0, I is less than num rows, I plus plus. Then we do two loops, second one, for int j is equal to 0, j is less than j plus plus. Uh, from there, we just say puzzle of I and j is equal to um, math dot random times 9, because remember math dot random is inclusive of 0 but exclusive of 1, plus 1, and we had to cast this to an integer because math dot random returns a double. So cast that to an integer and semicolons, and that is it for part A of question 4. So for part B, we have write the clear pair method, which takes a valid row index and a valid column index as its parameters. The array element specified by those indexes, which has a value between 1 and 9 inclusive, is compared to other array elements in puzzle in an attempt to pair it with another array element that meets both of the following conditions. The row index of the second element is greater than or equal to the parameter row, and the two elements have equal values or the same, or their values sum up to 10. If such an array element is found, both array elements of pairs are cleared, set to 0. So that's what cleared means, and the method returns true. If more than such array element is found, any one of those identified array elements can be used to uh, complete the pair and can be cleared. If no such array elements is found, no changes are made to the puzzle, and the method returns false. And here are some examples that we have here. So let's write it. So we're traversing our array starting at a specific row. So for int I is equal to row, and I is less than puzzle dot length I plus plus, since we're only seeing the rows including or not including the row. So then we want to see each column. So for int j is equal to 0 and j is less than puzzle, the row index I, dot length, and then we have j plus plus. All right. So the very first thing that we want to do is we don't want the case where we're trying to so let's say this one, right? 0, 1. So that's going to be this index over here. So essentially, we start at 0, 0, but we don't want to have the case where we get a false positive because it just evaluated itself. So what we're going to do is, in a first piece of logic that we'll do is write if uh, I is not equal to row and j is not equal to column. So we're not evaluating the one that the array element that we passed. Then we say if puzzle of I and j are equal to puzzle of row and column, uh, or so that's one of the case, so they're the same values, or they're the addition of their values is equal to 10. So uh, present that to puzzle ij plus puzzle row column is equal to 10. If any one of those conditions are true, we clear them, which is puzzle I j is equal to 0. And puzzle row column is also equal to 0. Then you just return true. And then the base case is that you return false. So those are the solutions for the 2025 AP exam, AP CSA FRQs. If you have any questions about it, feel free to comment about it. I will try answering them if you have them. And yeah, uh, this has been Mr. D. Make sure to like, comment, subscribe to Mr. AP.